Well, welcome back. Since we left off in the last video, of course, I went through a use of the change of base theorem, but these aren't the only tricks that we know when it comes to logarithms. There's some more right here. We actually discussed these in the previous section, but they're worth looking at again because we use these all the time. These properties, I consider these properties of logarithms. These properties of logarithms go along with certain things that we already know about exponents. And if you recall from our definition of a logarithm, we had stated that, well, logarithm base x of, let me write this out, uh, we write that the logarithm base b of x is equal to y if and only if x equals b to the y. So these rules actually apply, and they apply both ways, by the way, to what we're dealing with right here. For example, when we say logarithm base b of 1 is equal to 0, well, why is that? Well, the answer to that question is most definitely because we know that 1 is the result of raising b, the base b, to the power 0. Not only that, we say the logarithm base b of b is equal to 1 because we know that b is the result of raising a base to the first power itself. And it doesn't matter what base we're talking about. If, for example, we're dealing with this expression, we could say, well, if I knew that I was taking the logarithm base 3 of 3, I know I should get 1 because 3 to the first is equal to itself. So each of these properties are things that we used when we were graphing a logarithm. There was another one, we didn't quite state it, but the logarithm base b of b to the x is just equal to x. If I were to rewrite this using my rule above right here, I would look at this and say, well, that just simply says that b to the x is equal to itself. Because this base x is being raised to this power x to give me the result b to the x. Now, how would I use that? Well, every time that I deal with a logarithm of which I have some even power of the base, that makes it nice and convenient. If I were to look at the logarithm base 5 of 125, I know what the answer to that one is because I know that what I'm actually evaluating is the logarithm base 5 of 5 to the third power. That is, the exponent must be 3. In a sense, this would be considered an inverse function property of a logarithm. It says that since the logarithm base b of x and b to the x are inverses of one another, then they undo each other and give you the result x. And so we can actually look at it the other way around because our reverse way of looking at an inverse function is that b to the logarithm base b of x should also equal x because these two functions undo one another. And this is a useful property, as we'll find later when we're solving these logarithmic equations. But we do definitely want to keep these properties in mind. Okay, so we've said enough about those. What about our main properties? There are three main properties that we always use when it comes to dealing with logarithms. The three main properties right here are the following. We say that if we have a logarithm of a product, it's the same as the sum of two different logarithms. So let's take a look. What does this one say? In this particular property, we're actually saying that if I had an expression like the logarithm base 5 of 35, I might be able to rewrite this by treating it as the logarithm base 5 of 5 times 7. And so if I split it up, I could treat this as the logarithm base 5 of 5 added to the logarithm base 5 of 7. And of course, logarithm base 5 of 5 is 1. So whatever the logarithm base 5 of 7 is if we add 1 to that value, we should get the same thing as the logarithm base 5 of 35. And you can verify this for yourself using your change of base theorem and a calculator. And I might actually encourage you to pause the video right now and try that out. We have a second property of logarithms that says the logarithm of a quotient is the same as the difference of two logarithms. So in this particular case, in my example here, I say, well, if we look at what this property means, it means take the logarithm base b of m divided by n, and it is the same thing as the logarithm base b of m minus the logarithm base b of n. So as another example right here, let's take a look at this example. We've got the logarithm base 3 of 7/9. Well, by this rule, this actually means that we're going to be taking the logarithm base 3 of 7 minus the logarithm base 3 of 9. And we actually know what this logarithm base 3 of 9 is, because we know that 3 has to be raised to the second power to get 9. And so we could rewrite this as the logarithm base 3 of 7 minus 2. And if you actually go through and work this out, take the logarithm base 3 of 7, subtract 2 from that number, you should get exactly the same as if you used your change of base theorem and evaluated logarithm base 3 of the fraction 7/9. Okay, one more property that we should certainly know, and that is as follows. Let's take the logarithm base b of m raised to some power p. What does that give us? Well, it is the same as p times the logarithm base b of m. And I'm going to prove these statements in a separate video here a little bit later. But for right now, the main idea that you should have is that if I have an argument raised to a power, it is the same thing as the power times the logarithm base b of that argument m. So if I say logarithm base 3 of 81, in effect, I'm using this same rule again. What I'm saying is that, well, I know that I could evaluate this by saying, well, I know that 81 is 9 squared. How does that help me? This is the same thing as saying 2 times the logarithm base 3 of 9. Now I know what the logarithm base 3 of 9 is. That's 2. Right? So this is like saying 2 times 2, or 4. But if I were to go back, of course, I recognize that 81 is the result of raising 3 to the 4th power. So I probably could have guessed that beforehand. Nonetheless, this is a very handy little powerful rule. And I should also point out that this property is not the same as raising the entire logarithm to a power. It's only when the argument is raised to a power, right? So in this case, it is not, all right, emphasize this, not the same as saying the logarithm base b of m raised to the p. This one cannot be evaluated using this rule. Okay? So be very careful. It's only when that argument is raised to a power that we can do that. Okay, more to come.